Hi, my name is Rupert Osborne, and I'm one of the technical product managers of Micromine Origin and beyond. In this video, I'll introduce you to Micromine Origin Grade Copilot, our neural network modeling tool, which is now included in geology modeling and resource estimation cloud license subscriptions. Numerical data, such as grades, and categorical data, such as rock types, can be processed together or independently to create plausible models to be used for exploratory data analysis and model validation. In addition to the Resource Modeler Copilot module, you'll need to be logged into Nexus to use the tool. Nexus is our cloud-based platform where you can store data or use the cloud-based processing. Currently, in this project, I'm not logged into Nexus, and I can tell this because I don't have a little green light down in the bottom left. To fix this, I can go to the Nexus tab and click on Sign In, and then I need to enter my Nexus login details. If you don't have a Nexus account, you should contact your business development manager who will be able to set one up for you. Nexus accounts are free for people with a Micromine Origin subscription license. Once it has verified your credentials, you'll be asked whether you want to link the project to a Nexus project or if you want to skip this. You would need to link the project if you want to use Nexus storage services. For this project, though, I don't want to do that. I only want to use Nexus cloud processing, so I can skip the linking process. Once everything is correct, I should have a little green light down in the bottom left corner where I can see, when I see this green light, I know that I'm connected to the internet and I'm signed into Nexus, so I can use the Grade Copilot. In this video, I'll show you how to set up the tool and give you some tips. I'm going to skip over a fair amount of the options because in the majority of situations, these options are not needed. I think it's generally best to run a model using the basic default parameters first and then start tinkering with the more advanced settings and things like guide wireframes or guide fields if you find it is necessary. Tips on using those options will be in the following video. Okay, so I'm going to model this data. I have a composite file containing some iron grades and a column containing the rock types. What happens is we set up the form where we provide the data that needs to be modeled. Micromine Origin then prepares the data on your computer and sends it up to the cloud for processing. In the cloud, we train a deep neural network on your data, and then this neural network model is sent back to your computer. The neural network model now has the ability to predict the attributes that you modeled at any point in space. Once you have the Copilot model back, we can query it for all the required locations, like all the blocks in the block model, and you can keep the Copilot model file so you can use it to predict values for a different set of points without retraining the model in future. Right, onto the form. So you can find the Grade Copilot tool on the block model tab right here on the called Grade Copilot. Click on that, we can load the form, and you can see we've got two types of input data. We can either take a sort of a data file with XYZ coordinates, or we can take a Copilot model file. The Copilot model file would have been output from a previous run of this tool. We can select to model numerical data only or categorical data only, or we can do both at the same time. In this situation, we're going to do both at the same time, and I'll just set it up quickly to show you the basic use. So here I've selected my composites. It's generally best to use composited data. It's not totally necessary, but for the same reasons as you tend to use composited data for any kind of 3D modeling, I recommend using some composited data. And it's generally quite important to have representative data as well. So if your drill hole sampling has been selectively sampled, so you haven't sampled those low-grade intervals, it's probably a good idea to fill those low-grade intervals with new intervals using the Insert Missing Intervals tool, and replace any blank values with default low-grade values, because we know that they're going to be low-grade, so we need to help the Copilot and tell it them that they're low-grade. So we've selected our data, got the coordinates in there, and then we can go and select our numerical fields. So I should just point out that you can see when I'm not going to model categorical data, the categorical tab disappears. So we only see what's necessary. So in this case, I'm going to model iron. I can model multiple attributes at the same time, but it is important that you have all of the data for all of the attributes that you're modeling. So every row in every sample would need sort of the iron and the silica. In this case, I've got a whole load of silica, missing silica values, so I'm not going to model silica at the same time because only those rows that have all of the data will be considered by the Grade Copilot. I'll come back to background grade in the future. We won't use it in this run because we're going to use a very basic run of the tool. So we just set up our iron as our attribute. We can choose our categorical field. So in this case, it's just going to be list simple. And this auto populates with all of the unique values that are in that file. That what happens there would be the same as if I press this. We could load it from a color set or a hatch set if we wanted to, or we could click on this to assign and group things together. If we wanted to, say, for example, group the B and the cover into a single rock type. We've got the option to use a background category if we wanted to. And in this case, I will write the confidence categories. So what will happen for this, if I select this, is I'll get a column, a new set of columns in my output file. So in this, I've got 7 different columns, 7 different rock types. I'll get 7 new columns, each with a number between 0 and 1 for each block, which defines the confidence that that block is that sort of rock type. Now, the sum of all of those numbers will add up to 1. So it's 100% confident it's one of these rock types. It's not uncertain. It's not sort of globally aware outside the bounds of the data. We won't use guide wireframes in this situation. And now we go to the options tab. So we can either wait for the model to compute, or if we don't click on this, if we click off this, the model will run in the background and then will notify us when the training in the cloud has been completed and we're ready to download the model. I'm not going to decay to a background grade, and I'll just leave the model space transformation as it is, and the model fitting we'll just leave as it is as well. Then we can click on output, and this is going to be the name of the Copilot model file. So in this, I might just call it quick test. So when the model is completed, I'll have a Copilot model file that I could, if I wanted to, select this file, hit back here on the input tab, feed it in here, and use it to predict the values for a new set of points. So this is the Copilot model file, which is like the neural network model. Now, I can't look at that file. So what I want to do is write the results of that modeling out into a file that I can actually look at. So I can either create an output file or I can write it to an existing file. We might come back to writing to an existing file in another video, but in this case, we'll just create the output file. And I will select to write the distance to the closest sample as well. That's probably a good idea. So let's do this. I'll just call it PM for block model quick test 1. So I can create a block model file, or I can create a volume file. At the moment, a volume file can only contain numerical data. So anything that we've tried to model in the categories won't be included in this volume file. We'll fix that up probably for future release. In this, volume files are pretty good, especially when you've got very large block models, because you can display and view a volume file much more sort of slickly. It's a much smoother process than a block model file. It's easier on your GPU. So in this case, though, I'm going to select to model a block file. I'll click on my block definitions, and it opens up your block model extents form. I can just click on the calculator here to calculate the minimum maximum. As normal, I can click on edit extents to move these sort of boxes around a bit, sort of enlarge it to cover, to extrapolate a little bit of information if I wanted to. It's looking okay. I'll just make sure I go above there. Press escape, and it brings me back to the form, and I can select my block size as well. Now, selecting your block size, it's probably what I recommend is using a reasonably small block size, especially for this. Especially if you're using these models for visualization tools, because what the neural network is doing is it's just trying to providing we've got the discretization set to 111. What this is doing is it's all only trying to predict what a sample grade would be if there was a sample in the center of that block. So it's trying to do it on sample size support. Now there is a little bit of smoothing, so it won't do it perfectly, but normally you'd want the blocks for this to be smaller than you would do for an ordinary Krieg estimate or an inverse distance estimate, because those are averaging techniques, and this isn't sort of strictly speaking, it's not an averaging technique. If you are going to use a larger size, then you're probably best off using some discretization as well. So I'll just show you that. So in this case, I'm going to use 10, 10, 10, because I know that that's enough high resolution enough to pick out the features in this model. And if I wanted to, I could use these kind of divisions. So if I put 2, 2, 2 in that would mean that each block is split into 2 divisions in the eastings, 2 in the northings, and 2 in the Z. So it's actually sort of 8 points, 2 times 2 times 2, there, like scattered through that block, that is actually going to predict. Obviously, if you use a very small block size and a large number of divisions for your discretization, you'll end up with easily like billions of points being interpolated, which can really slow down your computer. You can limit the maximum extrapolation. So this is the distance away from the drill holes or your samples that the model will populate those blocks for. In this case, I can turn that off because I'm just going to fill that entire cuboid that I've defined here. And you can also trim it to the topography. So I've got this Raven DTM called Topo Collars, and that's pretty much me. I'm good to go. So just to recap, you select your composite file. You can put in, you can select your numerical data. You select your category field if you want to. It's generally a good idea to model attributes together that have a reasonably strong connection or correlation. So if my geology was completely going a completely different direction from my mineralization, I'm probably best off modeling them independently. But in this case, there is actually a strong relationship between the lithology and the mineralization, so I'm modeling them together. We can just leave all of this set to the default. I'll just changing this off the wait for the model to compute in order to show you what will happen. We're creating an output file, writing the distance to the closest sample, and creating a block model and trimming to the topography. Okay, so now I'll press run. So it's telling me it's found 1,310 records with missing data for at least one column. So in this case, I know that I've got that many intervals where I'm missing the geological log. It's just a blank. So in that case, as I said, every record needs to have all of the data in order for it to be modeled. So in this case, it's just going to drop that 1,300 records. So it says, are you going to be happy with that? Do you wish to continue? I'll say yes. And it starts, now it's preparing the data. And in a moment, it's going to, there it goes. It's sent the data up into the cloud. Now I can continue using Micromine Origin at this time. If we'd left it set to the tick box on there to say wait for the process to complete, it would just be frozen in the same way that all the other Micromine Origin forms are. But in this case, we can carry on using the computer. You can check what's going on the tasks there. You can see I've got my quick test is currently running. If I wanted to cancel that, I can press stop, and in which case it'll be finished. You can't see the tasks. You can access that from the window. When it does finish, so it should, it's going to take maybe a couple of minutes for this file in here. I've got 18,000 samples, and it takes a couple of minutes to finish. As a sort of a guide, if you've got like 500,000 assays and you're doing a model on that, it might take 2.5 hours to finish. So you can see now I've got this, it's completed, and it's asking me, do I want to continue or do I want to discard? If I happen to be away from my computer and that had closed after that, like that, I can see that the model is finished because I've got a little red dot next to this notification bell, and that tells me, if I open that, it tells me what my notification is, and it says your quick test model has completed. Do you want to continue? So I click on continue, and it opens up the form again, just double checking that I'm going to sort of be using all of this. Like I can change these settings if I want to, but I won't. I'll just say run. And at this stage, we're creating the block model and we're inferring all the values from the neural network. So this just takes a minute or so to run, and then I'll show you the model. So this process can take a long time if you've got an awful lot of blocks, or if you're using a lot of a high level of discretization, or it's especially much slower if you are using, can be much slower if you're using guide wireframes. I'll tell you how many blocks I've got there once this is completed. Okay, looks like we're good. So now what I'm going to do is I'm going to load up the block model just to prove that it's worked. So here we are, we've got the BM quick test. Just to have a little look at it. So we've got 1,400,000 records in there. You can see for every block we've got 9 grade. We've got a log of what the rock type is, and we've also got the confidence of which rock it is. So this one, it's 95% confident it's an andesite, and it'll be a little bit confident that it's sort of other one of these other ones, T. And we've also got the distance to the nearest sample written in there. So I'll just quickly set this up. So we're just loading up the block model to have a little look at the iron grades. As I said, if you have got very large block models, then it's often quite a good idea to look at them as a volume file. You can see once we get up into the reasonable grades, it's actually done a pretty decent job of following the mineralization and identifying the structures that are present in there. There are some, it does do some squiffy things on the edge, because basically here at lower grades, it doesn't know that the rest of the world is low grade down in this direction. So if you do find, especially if you're modeling sort of gold deposits or copper deposits, stuff like that, then it's a good idea to use the decay to the background grade. But we'll cover that in another video.